Hi guys, welcome to Club for Academy. We are going to discuss about microservice interview question, scenario based interview question, which is part 1. Let's get into the session, guys. Thank you. Hi guys, this session we are going to discuss about scenario based microservice interview questions. So few questions I have prepared. So for now, we can go through one by one and we can discuss, right? So how you will face the interview in microservice. So first of all, they will ask about the basic questions like what is let's say CQRS. How do you implement CQRS? You will come across a question like command line query responsibility segregation. That is CQRS. How do you implement that? Like they will ask the questions. What is CQRS? Right? CQRS is a command query responsibility. Let's say I have microservice A and microservice B. Okay. So I have read logic and write logic. Okay, read operation and write operations. Right. So both operation needs to happen in a single microservice. Right. So let's say microservice A is going to write the data, write transaction, and microservice B is going to read the transaction. So both are different, both are going to access the same database, but similar data. Data is similar, right? So microservice, let's say to microservice B also, microservice A as the database, microservice B also as the database, right? Microservice A is pushing some transactions. Based on that, microservice B also require the data because microservice B is going to read the data. Read the data. How do we sync that? We cannot sync through like a backend process like ETL job. It cannot be done because the real time transaction, right? And if you want a single, we can use if you want to write a single database which is connecting to microservice A and microservice B is connecting. That is an anti-pattern because microservice every microservice has an independent database, right? So you cannot do that. How do we achieve that? Because microservice A doing some transaction in the database in its own database, but microservice B also require the data because it has to do some read operations. So in or microservice C is required or microservice D is required. There are multiple services may required. So how do you do that? So we need to sync the data, right? We need to sync the data. To sync the data, let's say we are going for event sourcing pattern, event sourcing framework. There are multiple event sourcing frameworks are there in the market. We can use that. How we can do that? We have to create a command line and a query gateway. We have to design that APIs, query gateway, command gateway, because the query is directly firing the domain object. With the domain object, query is directly firing uh, the microservice A and pushing the data to microservice B. Is a query. It's directly firing the query. Read query, write query. It is firing. So let's say microservice A is firing the write query into microservice B's database, and microservice B is reading the data, or microservice C is some read operation. So like that, query, if you want to retrieve the query, we cannot directly retrieve the query from microservice A to B or B to A. We cannot read the query. We cannot fire the query directly, right? We cannot do that because both are different independent application. Both are different microservices. So we cannot do that. So if I use REST API, let's say if I want to use REST API, that is also not possible because it's a synchronization. But we are making a call in the asynchronous way. Whenever any transaction is happening, it has to be in microservice A. It has to happen in microservice B also. The data has to be moved to microservice B. So based on the transaction. So this can be done only event sourcing framework only. This can be done, and we have to design appropriate APIs. We have to create a DTO object and query gateway, and that gateway is connecting the query, and then it is firing. It will pushing that data. So if you try in Google, you will get to know how do we implement CQRS with event sourcing pattern, right? How we can do that? You can check the implementation details. They will tell you how you can do that. They will create a domain object and how we can do that. We can check that, right? That's called CQRS. And what is service registry? Microservice architecture. What is service registry? Services is nothing but discovery, right? Let's say microservice A, microservice B, C, and microservice A itself, A has the multiple instances. We cannot say it's only one instance. It can have multiple instances. It can have 5 instances are for running for one microservice. Microservice A itself 5 instances. So how do you know that when microservice B is calling? How do you know which host is the microservice is running? Because 5 instances are running, right? How microservice B knows that? So it has to find out that, right? That's it has to find out the address, right? IP address. Then only you can call that microservice, right? That's why we are going for service discovery, right? The service discovery, we are using Eureka service discovery framework. We are using the 2. I think 8 versions, but 3.2 onwards we are using Kubernetes discovery. Kubernetes discovery, it will do the load balancing and service discovery also. Kubernetes will do that. So we have to write some Kubernetes scripts, and we have to deploy that. We have to create that, and we'll deploy. But locally it cannot be tested. Only the Kubernetes discovery can be tested only in the Minikube. We can deploy the microservice A and B, and then we can make we can get the service name, and because service name will be single in Kubernetes, service name will be only one, because only one service name, but pod could be multiple pods, right? We're launching the container, it could be multiple pods, but service there should be only one service. That's why service name colon port number is unique, right? So if we that address, we will call that particular microservice, right? That is called Kubernetes discovery. So it will automatically detect that microservice. So we have to use the dependency like Kubernetes client dependency. So we have to use that, and both microservice. So automatically it will detect that, and this is straightforward changes. But in scripts we have to do some changes. You can search it. I have already given the detail in my LinkedIn page how to do the Kubernetes discovery. I have written the scripts, step by step article I have given, so you can go through that, and you will understand that how you can do the discovery, right? So this question you will come across when you are attending the microservice interview, microservice interview questions. And then uh, microservice, how do you debug the microservice? Because microservice, it could be many, right? It could be 50 microservices or 30 microservices, or it could be multiple microservices would be there. So how do you debug that? Let's say microservice A is calling B and B is calling C. So how do you track the microservice request? So that's called tracing ID. So microservice will always use tracing ID. Tracing ID is independent for every microservice. If you go and see the using the tracing ID, we can check what is the request and response. But tracing ID and span ID will be there. Span ID is referring the flow of the microservice. Let's say read operation, write operation, delete operation. We'll do multiple operations, right? That operation is referred by span ID, but microservice request is tracing with the trace ID, right? So trace ID is independent. Trace ID is unique. Let's say trace ID is microservice A as a trace ID. So using the same trace ID, we can find that across the flow. Microservice B using the trace ID. Okay, what request went on? We can check that, right? So request ID is independent, but trace ID is independent for that flow, for that for that call, for that request. So let's say I am going to push the customer details, get customer details. So microservice A is calling get customer details to microservice B. So what is it create a trace ID. So that same trace ID will be using microservice B. If you want to trace that, you can go and check in microservice A what is the trace ID. Using the trace ID, we can go on microservice B. We can check what is the trace ID. So using the trace ID, we can check, okay, this is the trace ID. Okay, this is the flow which is referring. And if you want a particular microservice request, that's a request ID will be there. That is unique for every microservice, right? So this is how we are tracing the microservice. That tracing, we are using micrometer. Prior to that we are using sloth. Now we are using micrometer dependency. Microservice dependency we are using for tracing the microservices, right? We can use that. And then microservice design pattern. The design pattern means if you go through internet, you can get multiple
things actually design pattern. There are multiple design patterns are there, right? Decomposition patterns are there. Decomposition means how do you decompose a microservice? Microservice can be decomposed by using business capability. Based on the business, you can decompose. Like if you take order microservice, product microservice, order history microservice, so product detail microservice, like that we can split the microservice into multiple pieces. There's another way is sometimes some microservice is very complex to decompose by business capability itself. Then we are going with the DDD approach, domain driven approach. This will be decomposing based on the bounded context and subdomain. So it will be subdomain and business context. Both it will be taken and it will be decomposing the microservices, right? So that's called DDD approach we are using. Business as well as it will small business unit, it will decomposing that, using that decomposing the microservices, made the building the microservice. And strangler pattern, so this is also part of the decomposing pattern only, because in microservice it's not easy to immediately decomposing that, right? Because monolithic applications are already running in production, but we want to converting into the microservice architecture, right? So for that, what we need to do, we cannot directly taking the monolithic architecture, and we cannot directly divide the decomposing the business microservices, and we cannot deploy it directly to the production, right? It's very complex. So that's the reason we are using strangler architecture, strangler pattern. So we have to break up the traffic. Let's say when we are let's say I'm going to product microservice, I'm going to separate that, right? So what you know, product page, so we have to decomposing that. So we have to distribute the traffic. So we have to create a same URL, and the old microservice can distribute the traffic 50%, and new microservice architecture we can distribute the traffic to remaining 50%. Once the microservice is response is good, and no transaction failures or no errors are happening, then we can move gradually all the traffic to microservice architecture for the particular microservice, right? That's called blue green deployment. We used to call blue green deployment. Blue green deployment means the green deployment is already in production, let's say monolithic architecture, but blue is the microservice architecture, microservice. So we cannot immediately push the changes to the production, right? That's why we are going for linear deployment, or canary deployment. So we can splitting the traffic distribution, and based on the success rate, we will gradually increase the traffic to the new version of the microservice, and then it will move the traffic to 100%. So that's what we used to do in microservice architecture, right? So this is one of the pattern. Just an example is that decomposition pattern. Like that, we have like circuit breaker pattern. Is a circuit breaker. What is circuit breaker in microservice? So circuit breaker, when microservice A is calling to microservice B is not at all responding, service is down. So what will happen? Microservice A is all the request will keep on calling. So due to that, it may cause some memory issue. Some applications goes down. So it will other microservice also will application will goes down, right? So microservice A also goes down. So this is not good, right? So when microservice B is completely down, so we have to respond something like we are using timeout, alias scenario timeout, but timeout is something like still it will receive the request, right? Request is keep on going, but timeout will go to the timeout, getting to the timeout scenario. It will wait for 1 minute or 2 minutes, and then not timeout the service. Let's say 10,000 calls are firing, right? So 10,000 time timeout happening means it's very huge, right? It can definitely will create memory issues, and it will thread dump will be created, lock thread or stuck thread will happen, and both applications goes down. So due to that, what we are using to overcome this issue, microservice A is implementing the circuit breaker. Circuit breaker, what will you know? Circuit client and microservice B is also including circuit breaker. So whenever service is down, my circuit breaker is there are three states are there: open state, hop open, and uh, and then closed state. Whenever service is down, microservice will do the open state. It will go to open state. Open state means microservice B will not allow microservice A to call B. BA is calling, but it will not go to the calling the service. Instead of that, what it will know, it will get into the fallback mechanism. It will go to the fallback scenario. It will execute that. Fallback means something like data. It retrieve the data from the database, or it will just showing the error message. Something it will show that, right? And then let's say Microservice B particular service up. What it will know, circuit breaker is keep on increasing the traffic, like it will allow the 20%, 30%, 50%, and 100% is fine. Then it is allow the 100% traffic, and then circuit breaker is moving to closed state. So this kind of configuration, while implementing circuit breaker, we can take care of that, like how what percentage of time it has to increase the traffic, how much it has to increase every seconds, and then how long it has to be hold. So all the configuration we can do in circuit breaker, right? That's the circuit breaker is a fault tolerance, and it's reduce a failure, right? That's called circuit breaker we are using. And then if you Google it, you will get multiple things regarding the micro design pattern. If I see and decompose and API gateway. See, if you see API gateway, what do you know? API gateway, we have right one is a single entry point for all the microservices. Because if you have 50 microservices, every microservice A is calling B or calling C. You know it's no need to call a producer microservice is explicitly. Consumer microservice, no need to worry on the producer microservice. It has to call via API gateway. API gateway will be taking care of that. It is taking care of routing logic, caching. So that will taken care of everything. Taking caching, and it will give a single entry point and aggregating the response of the producer microservice, and then finally it return the aggregated response to consumer microservice, right? So that's what API gateway will do, right? So API gateway is a single entry point. When consumer microservice is calling to producer, so producer microservice no need producer consumer microservice no need to worry about what kind of URL, what kind of call, so what kind of aggregation, what kind of format needs to be converted. So everything will be taken care API gateway. API gateway will be converting the even one protocol to another protocol. So all those things can be taken care by API gateway. Right, this aggregator pattern is something like when consumer is calling to multiple microservices, it will aggregate all the response and return the single response object. So you may come across this question when you are calling the microservice A is calling microservice B, and there are multiple requests are coming. So how do you achieve that performance? How do you debug that? You can say aggregator. You can aggregate the response, a single response, and then we can return it through API gateway. You can answer that question. And then API gateway itself will ask us a different question. Instead of asking entire design pattern, they may ask different particular design pattern, like saga pattern, what it will do, what is distributed tracing. Externalizing configuration is nothing but configuration is separated, and it will not be with along with the application, so it will be separated configuration. That's what externalization. And service is circuit breaker, so blue green deployment. So blue green deployment we discussed it, right? So that kind of questions you may come across when you are attending the microservice. And microservice 12 factor principles. 12 factor principle app principles means so there are microservice disposability. Disposability means when the something is application is shut down, something is shut down, it should not happen any outage. Let's say in Kubernetes we are going to deploy the application. So already application is running, that is green application. You are going to deploy the new version, that is a blue version. You are going to deploy that. What will happen normally, normal traditional, this when we are deploying something, we need to shut down the application for some time, and then for the new deployment, and then we can see the outage or a few minutes, right? A few minutes or half an hour it may happen some outage. After that only our application is up, because we may write as trigger some database queries, database data import export or something. We will create a table schema. So but in modernization architecture there won't be any outage, right? There won't be any outage. That's because microservice, if you are calling blue version going to deploy, That is called rolling update. Rolling update, what will know? It will not immediately update the new version to that. So it will gradually increase the traffic. First 20%, 30%, 50% are blue, and green is live 50%. So once blue is completely working fine, then it's moving 100% traffic to blue deployment. Blue becomes green, and then green deployment is existing green deployment is completely removed. Sometimes when our green is live, blue is deploying, sometimes crash the image due to image is not able to pull from registry. So what will happen is immediately the failure container, failure microservice will be removed, and then it will retain the old microservice, old version of the microservice. So that's called dispersibility. And port binding. Port binding is another part of 12 factor app principle. So port binding, so if you take Spring Boot application, the port application server or app server or web server will be there along with the application automatically. We no need to map or configure the web configuration in the application, right? When you are creating the Spring Boot application, what you will know? You are creating the Spring Boot application, you are giving the port number like 8080 and then running the application. It's automatically running. We are not configuring any Tomcat server or any server configuration, nothing we are doing. It's automatically servers are configured. That's called port binding. Port is automatically configured. That's called port binding, we used to say. And processing. Processing means microservice request is always stateless request, stateless call, because it will not maintain any state. State means if you want to still maintain when you are moving to monolithic to microservice architecture, some edge case scenario, then we can use sticky session kind of things, but that is not preferred approach. So whenever microservice A is calling B, it's a stateless call. There it will not maintain any state, because if you want to scaling the application like horizontal scaling, or if you want to do that scale or scale up or scale down, so we can do that because it's stateless, right? Any of the servers it can connect, it can do the scaling, number of instances can be increased and decreased. So because it's not tracking the user request, right? It can go to any of the instance, any of the server, any of the instance, it can go there. That's why we are not using microservice is a stateless architecture. Stateless, it will not maintain any state in the request, stateless request. So that's called processor. If you see microservice 12 factor principle, you can check multiple things on Google. 12 factor app principles. This question you may come across. So you can boom this site. You can check that. Yeah, dependency. Dependency means microservice in Spring Boot, how dependency are mapping. We are mapping the dependencies or pom.xml, but all the jars are packed to the some external server. It will be hosted. That's called dependencies. And configuration is one of the 12 factor app principle. So configuration is we are moving all externalization configuration, right? Configuration will not be along with the application. So configuration value. And packing services. Packing services means, let's say if I want to configure any of the services like the MySQL services and we are using Spring JPA, right? The code we are just simple configuration, we are just using the dependency and configuration. But when when you are moving to another database in the future, there will be no changes. Only the configuration values or map the dependency and application or property value. The configuration value will be changed, but the code changes. There will be no changes on the code level, right? So that's called packing up service. Any services you can easily integrate that. If I want to RabbitMQ, what we will do? RabbitMQ dependency client we will use, and then certain URL configuration, and then the logic we will use RabbitMQ APIs, and we will use that. We will use the communication parameter. We will use that. But tomorrow when we are changing that, we are just changing only the config. Not this is particularly like database related. Even not, we cannot take example of RabbitMQ because RabbitMQ API we will use internally. So if you are using like relational database, right? So MySQL we are using, and then we are going to use another relational database. Only the configuration and dependency changes are required. There will be no changes in the application. That's what is referring the packing services. Build and release, and you can do CI/CD pipelines we are handling in microservice architecture, right? That's what it's referring. Process, as I said, is a requests are stateless in microservice. And then port binding. Port binding we discussed. And concurrency. So this is one of the 12 factor app principle. concurrency, and then disposability we discussed, logs. So like that you can check in the Google, and you can study that 12 factor principles and API gateway importance. You can go through more on that in the internet, and you will get online, you will get them detail on that. And how to create Docker image. You can create Docker image like Maven, Maven dependency we are adding that, and we can do that in the Maven configuration, that build a Docker image. And that's not a recommended way. Recommended way is we are creating the Docker image. So we are creating the Docker image. So Docker image Docker file. So the Docker file, Docker file we will create Docker file. So Docker file will be we are creating we can go to any of the Visual Studio, create a Docker file. It's a text extension only, so there is no extension, text extension. Docker D should be caps, and we are creating the Docker file, and then we are creating from the base image, and what is the base image, and then the jar file which we built that in the Spring Boot, the jar name we have to give, and then we have to give the custom jar name, and then we have to build compilation command we have to give, and it will automatically build the Docker image. And we will go to the Docker. Docker needs to be installed before that, and Docker we can go there, and Docker build dot -t, and then Docker image, and then we have to tag the image and pushing the image to the registry, right? And then we can go to the Kubernetes script, and here I ask the same question, Kubernetes also. Kubernetes script, and we can map that image path, and then we can deploy into the Kubernetes. What is Kubernetes? Kubernetes is a deployment architecture where we can we can set up the cluster using Kubernetes. Like my previous video I shared what is Kubernetes, or what is a pod, and pod is launching the containers, Docker container, and then it in the cluster, and then it will be number of nodes will be there. Nodes are in the VA virtual machine, number of nodes, and each node has a multiple pods are running, right? So under the architecture and other things, you can check my video. And my Kubernetes services, what are they? We can cluster IP services and external IP services like node port and load balancer port. These are exposing to the outside world. The Kubernetes deployment are exposing to the outside world. And if you see the cluster IP is we cannot expose to the outside the world. It is accessible within the server, within the cluster. Because if a database could be a cluster IP, because database application will not be exposing to the outside world. It is accessible by the application. So within the cluster only this can be accessible. So that should go to the cluster IP, right? If something which are going to expose accessing via browser, then it has to go to load balancer or node port, right? The service. That's the Kubernetes services. And then circuit breaker we have discussed already. So these are the some questions. These are the few basic questions you may come across when you are attending the microservice interview, right? But still, if you see particularly for Java microservice, then we can discuss about next session Spring Boot in the interview questions. What are the interview questions you come across? We will discuss on that, right? For now, these are the questions you may face during the microservice interview questions, right? Thank you for watching and listening. We are looking forward to join our Cloud4 Academy.